This is 3.3 factoring, and we're going to be factoring binomials and trinomials with a leading coefficient of 1. So let's start with factoring binomials and talk about what factoring is. Factoring is dividing. So I'm going to write that up here because that's really important. So factoring is dividing. It's undistributing. So it's assuming somebody has done the distributive property and you're trying to back things up into what the problem originally started as. So if you look at this first example, I want to figure out what somebody multiplied by both terms to get 3x minus 6. Well, both 3x and 6 are divisible by 3. So I'm going to divide both terms by 3. And when I write my answer, I'm going to put that 3 in front of parentheses. 3 divided by 3 is 1, so that's going to leave the x. Then I have my minus sign, and then 6 divided by 3 is 2. So somebody took 3 times x minus 2 and did the distributive property to get 3x minus 6. And we can double check our answer if we want to, because I could go ahead and I could do this and end up with what we started with. Same thing with 2x minus 10. Both of those are divisible by 2 nicely. And so I'm going to write the 2, parenthesis, and then x minus 5. Sometimes what you're factoring out is not the first number that you see. So if we look at the next example, in the next example, we've got 12x minus 28. So we have to figure out what we can divide 12 and 28 by so that we can factor that out. Well, I know 12 is divisible by 2 and 6. 28 is divisible by 2, but not by 6. 12 is divisible by 3 and 4. And 28 is divisible by 4, but not 3. So the biggest number that we can pull out here seems to be a 4. And so I'm going to go ahead and I'm going to take out that 4. 12 divided by 4 is 3. So we're going to have 3x minus, and then 28 divided by 4 is 7. If you're not sure what to factor out, you could always start with 2. So divide both numbers by 2. And then see if there's a bigger number. So divide both numbers by 3 and see if you get something. Divide both numbers by 4 and see if you get something. For example, this next one, I see 15 and 25, and the 15 has a y attached to it. Well, 15 and 25 both end up with a 5, so I bet I can divide this by 5. So I'm going to take that 5 out. I'm going to do 15 divided by 5, which is 3. The y goes along with it, and then 25 divided by 5 is 5. And I can double check. In the parentheses, are 3 and 5 both divisible by the same thing? Well, no, because they're both prime. So I'm done. For the next one, the numbers don't have anything in common, but they both have x's. So I'm going to go ahead and divide out an x. So I'm going to put that x in front. I'm going to put down my 3 because I'm not changing any numbers. If I have x squared and I take out an x, I'm just left with 1x. I had 2. I took out 1, so I'm left with 1. And then minus, and then I had 1x for the second term. I took it out, and so I'm just left with the 5. We can even do this with 3 terms. So if I look at 4x minus 8y and 12, I want to know what I can divide all 3 of those by. Well, let's try 4, because 4 is the leading number. So if I do divide by 4, divide by 4, divide by 4, I'm going to take a 4 out. 4 divided by 4 is 1, so that's just going to leave me with the x. Negative 8 divided by 4 is negative 2, so I'm going to have negative 2y. And then 12 divided by 4 is 3. And that's factored. Sometimes you'll have multiple letters, just like we had in the previous example. In the next example, both terms have a 2 and a 3. They don't divide by the same thing. Only one X in the first term, but both have a Y. So because they have that Y in common, I can divide out that Y. So I'll put Y in front of the parentheses. We'll do 2xy divided by y, so the y's will cancel. I'll just kind of draw a little slash there, leaving me with 2x. And then the 3y's will cancel, leaving me with the 3. Last example on this page, I see y's all over the place. I see 5, 2, and a -1, so those don't have anything in common. So it looks like the y is the only thing. So I'm going to go ahead and divide by y. That's what's going to go in front of the parentheses. I have a 5, I have an x, and then I had 3 y's in the first term. I took out 1, so I'm left with 2. In the second term, I have a 2. I had 2 y's, I took out 1, so I'm left with 1 y. And then I had the -1, which is really important because the y's cancel out, so I still have a -1. Now let's factor with 3 numbers. So there's a process for this one. When you have 3 terms, you look first at the third term. So the third term is a 20. I'm going to do a factor tree on 20, and actually let me do it over here. So I take that back. I'm not doing a factor tree, I'm doing a factor list. So let me write that down. So this is a factor list. So for 20, what times what gets me 20? Well, to make sure I get them all, I start with 1. I'm going to say 1 times 20. Then I'm going to go to 2. 2 times 10. 3, no. 4 times 5. And 5 I already have because I already have 4 times 5. I want to know which pair of numbers is going to get me a -9. How can I make a -9 using that pair of numbers? Well, 1 and 20 are too far away, right? 20 minus 1 is 19. 1 minus 20 is -19. I could get 21 out of that. That's not going to get it. 2 and 10, well, 2 plus 10 is 12. 2 minus 10 is -8. That doesn't get me -9, though. It looks like -4 and -5 is going to get me -9. So trinomials come from double distribution. So I'm going to put my -4 and my -5 in the second position in my 2 binomial answer. To get the x squared, I do x times x. Okay, and if I do the box on that, or if I do double distribution, that will get me my original problem. Let's try the next one. So for the next one, I'm going to do a factor list. I'm going to take 12. I'm going to ignore the minus for a second. 12 is 1 and 12, 2 and 6, 3 and 4. So if I do 1 plus 12, so I'm just doing some experimenting here. 1 plus 12 gets me 13. That doesn't get me the 3. And 1 minus 12 gets me -11. That doesn't get me the 3. So I'm going to move on. 2 and 6, well, 2 plus 6 gets me 8. 2 minus 6 gets me -4. So that's not going to get me the 3. 3 plus 4 is 7. 3 minus 4 is -1. I've gone through all of my factor list, and I haven't found a pair of factors that will get me a +3. So what this means to me is this guy is not factorable. So it is possible to not have factors. In the next examples, what we have to look at first is, do we have a GCF like we had on the first page? Can we factor something out before we do the factor list? So I look at these three terms and I see all three of these are divisible by 2. And 2 is the highest we can go because the 2 is the first number. So that means I can write this as 2 times x squared minus 3x, and then 36 divided by 2, that'll be minus 18. Now I'm going to look just inside the parentheses, and I'm going to do a factor list on 18. So 18 is 1 and 18, 2 and 9, 3 and 6. I want a factor pair that's going to get me a negative 3. 1 and 18 are too far apart. 2 plus 9 gets me 11. 2 minus 9 gets me negative 7, so that's too big. Let's try negative 6 and positive 3. So I'm going to do 2 times, and we're going to have a plus 3 and a minus 6, and I'm going to put my x's in the first spot. Let's try the same thing with the next one. With the next one, all three of these numbers are divisible by 3. So I'm going to have 3 times x squared minus 3x plus, that should be 27. And then I'm going to do factor pairs for 27. Well, factor pairs for 27 are 1 and 27, 3 and 9. Let's see, not 4, not 5, not 6, not 7, not 8. That's all of them. I hope. Yeah, that should be all of them. So 1 and 27, I want that to get me a minus 3. That doesn't do it. 9 and 3, well, that gets me a 6 if I subtract, but it doesn't get me a minus 3. So this is as far as this one goes. It factored, it just didn't factor very far. In the next example, this one is x cubed, but if you notice, all three terms have an x, which means I can take that x out. So I can write this as x times, then I'm going to have x squared plus 2x minus 63. So for 63, I'm going to do factor pairs. I'm going to do 1 and 63. Not going to be 2 because it's not even. How about 3 and 21? Let's see, does 63 divide by 4? I don't think so. Not by 5. Not by 6. How about 7? Yeah, 7 works. So 7 times 9. Not 8. And then 9 we've got. Okay, so there we go. I want a 2. Well, it certainly looks like plus 9 and minus 7 will get me a 2. So I'm going to go ahead and set up my factors. I'm going to put minus 7 and plus 9, and then put my x's in. For the next one, I don't see any common factors, so I'm just going to start with my factor list. So I'll do 36. 36 is 1 and 36. Let's see, 2 and 18, right? 8 and 8 is 16, yep. 3 and 12. 4 and 9. So I want a 12. Let's see, 9. Oh, I forgot one. The most important one. 6 and 6. That'll do it. So plus 6 and plus 6 will work. So I'm going to say x plus 6 and x plus 6. And because they're the same, I can write them as x plus 6 squared. Next examples. So I don't see any common factors because my leading coefficient is 1. So let me go ahead and do a factor pair list on 64. So 1 and 64, 2 and 32. Let's see, how about 3? Does 3 go into 64? No. How about 4? No. Wait, maybe 4? Let's check. 4 into 64 goes 16 times. Yes, it does. Not 5, not 6, I don't think. No, not 7, but 8 does. And as it happens, 8 plus 8 gets us the 16 for the middle term. So I'm going to write that as x plus 8 and x plus 8. And because they're the same, I can write it as x plus 8 squared. Okay, next example. We're going to do a factor pair list for 81. So 1 and 81, not 2. 3 and 27. 4, no. 5, no. 9 will work. 6, 7, 8. Yeah, let's do 9 and 9. And as it happens, minus 9 and minus 9 get you minus 18. So we're going to have x minus 9 and x minus 9. And because they're the same, we can write it squared. In the next two examples, we're missing something. We're missing that middle term. So what we're going to do is think of this as x squared plus 0x minus 9. So we're going to do our factor pairs, 1 and 9, 3 and 3. And we want the factor pairs that are going to get us 0. Well, to get 0, I can do a positive 3 and a negative 3. They're opposites. And so I can do x plus 3 and x minus 3. Same thing with x squared minus 49. I'm going to think of this as x squared plus 0x minus 49 and do factor pairs. So 1 and 49, not 2, not 3, not 4. Looks like just the perfect square, just 7 and 7. And to get the 0, I'm going to do opposites. So x plus 7 and x minus 7. So what we're leading up to with all of this, because this is the unit on solving, is we can solve by factoring. So on this next page, we're going to be taking our factor pairs and we're going to be solving by factoring. To solve by factoring, once you have your quadratic in two parentheses in intercept form, you're going to take each set of parentheses and set it equal to 0 separately. The reason you can do this is because if you have two things multiplied together and the answer is 0, one of them has to be 0 for that to happen. You have to do 0 times something or something times 0. So we say, what if it's both? And then I'm going to solve both of these by doing just regular algebra. So I added 6 to both sides of the one on the left and added 2 to both sides on the right. And that gets us our solution. So same thing with the next one. I'm going to do x plus 5 equals 0 and x plus 1 equals 0. And I'm going to subtract 5 and get x equals negative 5. And I'm going to subtract 1 and get x equals negative 1. So let's try this from the very beginning. We've got to factor first. So I'm going to do a factor list for 10. So 1 and 10, 2 and 5. I need my factor pair to get me a -7. So it looks like -2 and -5 will do it. So I'm going to write my answer as x minus 2 and x minus 5. And those both equal 0. So now this problem looks like the way the problem above it started. And so I'm going to take each set of parentheses and set them equal to 0 separately. For the one on the left, I'm going to add 2 and get x equals 2. And for the one on the right, I'm going to add 5 and get x equals 5. For the next example, same thing. I'm going to do factor pairs on 40. So 1 and 40, 2 and 20. I don't think 3 works. How about 4 and 10, and 5 and 8? 6 doesn't work, 7 doesn't work, so we're good. I need the pair that's going to get me a 3. Well, how about +8 and -5? So I'm going to do x plus 8 and x minus 5 equals 0. And then just like we did in the first line on this page, x plus 8 is equal to 0. X minus 5 is equal to 0. And so I'm going to do -8 to get x equals -8, and +5 to get x equals 5. Let's try another couple. So for the next one, I'll do factor pairs for 12. So 1 and 12, 2 and 6, 3 and 4. I need to get a -4. So how about -6 and +2? So I'm going to do x plus 2 and x minus 6 for my factors. They equal 0. I'll set them each equal to 0. Subtract 2 for the one on the left and get x equals -2. And add 6 on the right to get x equals 6. Same thing for the next one. I'm going to go ahead and do a factor pair for 18. So 1 and 18, 2 and 9, 3 and 6. I need to get a -7, so -9 plus 2. So we'll do x plus 2 and x minus 9. And if you've noticed from all of these, when you set these binomials equal to 0 and you solve them, the sign changes. So in the one that we did before, we had x plus 2, the answer was -2. So for this one, x equals -2. For the one that we did before with x minus 6, the answer ended up being +6. So x minus 9 is going to end up being x equals 9. And this is the reason when we were doing intercept form that we had to switch the sign to get the x-intercepts. It's because we're setting them equal to 0. It's really important when you do this factoring that everything is equal to 0. Okay? So when solving, we'll say when solving, set equal to 0. So this first one on this last page is not equal to 0. To make it equal to 0, I'm going to subtract 18 from both sides. So I'm going to have x squared minus 9x minus 18 equals 0. And then I'll do a factor pair list for 18. 1 and 18, 2 and 9, 3 and 6. And I need a -9. So I'm going to try and choose 3 and 6. To do 3 and 6, I'm going to do minus and minus. That gets me my -9. However, these factor pairs have to also get me a -18. So while -3 and -6 get me the -9, they don't get me the -18. They get a +18. And so this guy turns out not factorable. And I'll write down here -3 minus 6 equals 9, but -3 times -6 does not equal -18, and both have to happen in order for this to work. Let's do the next one and see if it does work. So I'm going to subtract 36 and get x squared plus 9x minus 36 equals 0. Do factor pairs for 36. So we've got 1 and 36, 2 and 18, 3 and 12. That looks like it might work. It's 4 and 9 are the next one. But 3 and 12 looks like it'll get me 9 if I do -3 and plus 12. And sure enough, -3 times +12 does get me -36. So we can go ahead and say x minus 3 and x plus 12 equals 0. So x minus 3 equals 0 and x plus 12 equals 0. And if we do opposites, x equals 3 and x equals -12. Okay, couple more. For the next one, we could actually factor out an x. Both terms have something in common, so I could divide out an x. We're missing that third term, so I'm going to go ahead and do that. That's going to leave me with x minus 6 equals 0. X is very similar to some of the other numbers that we've been working with, some of the other factors, except it's x plus 0. So whenever you see an x, it's really an x plus 0 factor. And so we can say x plus 0 equals 0 and x minus 6 equals 0. Subtracting 0, we get x equals 0 and x equals 6. For the one on the right, it's not equal to 0, so we have to move the 9x. So we're going to say plus 9x and get x squared plus 9x equals 0. We're missing that third term, that constant that doesn't have an x. And so I can divide both of these by x and get x times x plus 9. And that's going to be equal to 0. And remember, an x by itself is really x plus 0, like we did on the left. So x is going to equal 0. And if we do opposite for the x plus 9, x is going to equal -9. Okay, last example. When you have multiple terms that are kind of on the wrong side, what I like to do is make sure the x squared stays put. Okay, make sure the x squared is positive. So let me say make sure x squared is positive. So what I'm going to do is I'm going to move the 14x first. So -49 equals x squared minus 14x. And then I'm going to add the 49 and get 0 equals x squared minus 14x plus 49. And it's okay that this is backwards because it's the same thing as x squared minus 14x plus 49 equals 0. Okay, they're the same thing. So I'm going to do factor pairs on 49. So 1 and 49, 7 and 7. I want a 14, so minus 7s will do it. So I'm going to do x minus 7 and x minus 7 equals 0. Both of the factors are the same, so I only really need to solve one of them. I don't need to write x equals 7 twice. So there's just one solution to this one. And the reason for that is the x minus 7 is the vertex. X equals 7 is the vertex on this one. Last example. Again, I want the x squared to stay positive, so I'm going to leave it alone. I'm going to move the 3x. So we'll say 28 equals x squared plus 3x. And then we'll move the 28 and get 0 equals x squared plus 3x minus 28. I'll do factor pairs on 28. So 1 and 28, 2 and 14, 4 and 7. To get to 3, I need to do plus 7 minus 4. So we're going to say 0 equals x minus 4 and x plus 7. And if we do opposites, x is equal to 4 and x is equal to negative 7.